Elon Musk just made a jaw-dropping revelation. In a stunning move that has sent shockwaves through the world of aviation, SpaceX, in collaboration with the U.S. Air Force, has just revealed a $4 billion aircraft that promises to revolutionize the skies. Equipped with advanced technology and capabilities unlike anything ever witnessed, this groundbreaking aircraft is set to redefine the future of air superiority. What are the capabilities of this new jet? What are the similarities between Elon's new aircraft and the United States' sixth-generation aircraft? Join us as we unveil the $4 billion sixth-generation aircraft Elon Musk just revealed to the world. SpaceX has quietly bought a new airplane, a Boeing 737-800, and painted it in a striking gray and black design. It's not clear what the company plans to do with this aircraft, but it could be used as a corporate shuttle, a testing platform, or both. The unique paint job and possible use have led to comparisons with some of the most secretive 737s in the world. Boeing started working on the narrow-body 737 in the early 1960s. They wanted to build a plane that could be used alongside the Boeing 727. The 737 was meant for shorter trips, while the 727 handled longer routes. But the 737 became very popular in the airline industry and eventually replaced the 727. Production of the 737 began in 1986, after Lufthansa received the first plane. Since then, about 12 Boeing 737s have been made, and Boeing is still making the latest version, the 737 MAX. There are also almost 5,000 more 737s on order. SpaceX uses a Boeing 737-800, which is part of the 737 Next Generation series. This series was introduced in 1993 to replace older 737 models. The 737-800 has a better wing design, which lets it carry more fuel and handle a higher maximum takeoff weight. This formidable aircraft is powered by CFM International CFM56-7 engines that provide over 27,000 pounds of thrust. Boeing also improved the aircraft's avionics and added new interior options. Here are the 737-800's specifications. The Boeing 737-800 has a maximum capacity of 189 passengers, with a length of 129 feet 6 inches, a height of 41 feet 2 inches, and a wingspan of 112 feet 7 inches. It has a maximum takeoff weight of 174,200 pounds, a cruise speed of 455 knots, and a range of 2,935 nautical miles. The aircraft's service ceiling is 41,000 feet. SpaceX's second plane is a Gulfstream G450. According to JetSpy, this plane was first built in 2007 and is registered as N450GG. The Federal Aviation Administration lists TVPX Aircraft Solutions, a trust for aircraft, as the registered owner. But JetSpy says that SpaceX is the one using the plane. According to JetSpy, in 2024, the Gulfstream G450 registered as N450GG has completed 150 flights, totaling flight hours. These flights consumed nearly 170,000 gallons of aviation fuel, resulting in 1,610 metric tons of carbon emissions. The top 3 airports visited by N450GG in 2024 are Draffen-Miller Central Texas Regional Airport, Jack Northrop Field Hawthorne Municipal Airport, and Brownsville South Padre Island International Airport. This aircraft is an upgraded version of the Gulfstream 4, which was first developed in the early 1980s. The original Gulfstream 4 featured a stretched fuselage from the Gulfstream 3, along with new engines and other enhancements. Its first prototype flew in September 1985, and it was introduced in 1987. Introduced in 2004, there were further improved on the Gulfstream 4 with enhanced Rolls-Royce Tay 611-8C engines, providing nearly 14,000 pounds of thrust, a longer fuselage, the Honeywell Advanced Flight Deck Display Suite, better flight controls, and new landing gear. This aircraft has the capability to carry up to 19 passengers. It also measures 89 feet 4 inches in length, stands 25 feet 2 inches tall, and has a wingspan of 77 feet 10 inches. It has a maximum takeoff weight of 74,600 pounds, a maximum speed of 505 knots, a range of 4,350 nautical miles, and a service ceiling of 45,000 feet. What does Elon Musk's newly acquired aircraft have in common with the United States' next-generation air fighter, the NGAD, if any? The idea of a sixth-generation fighter jet marks the start of a new chapter in aerial warfare, featuring advanced abilities and the latest technologies. These upcoming aircraft are expected to change the game in air combat, offering better air-to-air fighting skills and the ability to enter heavily defended areas. Recently, several countries have revealed plans to develop their own sixth-generation fighter jets, highlighting a global effort to advance military aviation. The United States Air Force is a major player, working on the next-generation air dominance stealth fighter program. In 2013, DARPA Director Arati Prabhakar announced that the U.S. had started studying an air dominance initiative. This made aviation enthusiasts worldwide very excited, as the new aircraft was expected to feature the most powerful engines, advanced sensors, integrated artificial intelligence, and a swarm of drone wingmen. By 2016, the U.S. Air Force joined DARPA's research, launching the Air Superiority 2030 plan. The Next Generation Air Dominance Program is an advanced project by the U.S. Air Force to develop a new fleet of highly advanced aircraft. The main focus is on creating a manned fighter jet called the Penetrating Counter-Air Platform, which is designed to break through heavily defended airspaces and tackle the toughest enemy threats. What makes the NGAD program even more exciting is that these manned jets will be supported by unmanned combat aircraft, known as loyal wingman platforms. These unmanned aircraft will fly alongside the PCA, taking on tasks like surveillance, electronic warfare, and direct combat, all while being controlled by the human pilot in the PCA. This combination of manned and unmanned systems will create a powerful and flexible force that can adapt to various combat situations. The NGAD program isn't just about creating a better fighter jet, it's about transforming air combat entirely. By using advanced technologies like artificial intelligence, cutting-edge sensors, and new propulsion systems, the NGAD aircraft will be able to perform more effectively in the tough, contested airspace of the future. These innovations will give the United States unmatched control of the skies, ensuring air superiority for many years to come. One of the standout features of the NGAD program is its focus on flexibility and quick upgrades. Unlike older aircraft that took a long time to develop and were hard to upgrade, NGAD is designed to quickly incorporate new technologies as they emerge. This means the NGAD aircraft will stay at the forefront of military aviation, ready to counter any new threats from adversaries. The idea for this program started when the Defense Advanced Research Projects Agency explored concepts for future air superiority systems for the U.S. Air Force and Navy, targeting the 2030s. After completing their Air Dominance Initiative study in March 2015, DARPA's findings led to the launch of the Aerospace Innovation Initiative in 2015. This initiative aimed to develop prototype X-planes to showcase next-generation fighter technologies. The NGAD program is also changing how the Air Force acquires new aircraft. They are separating the design, building, and maintenance tasks and have allocated $9 billion to achieve this by 2025. The plan includes holding more competitions and frequently testing the designs to ensure they are effective. Although this project started with the idea of creating one type of plane, they are now planning to develop a group of different systems. At the core of this group is a manned fighter plane, supported by drones and computer systems to enhance its performance. The goal is to create a system that performs well in the Indo-Pacific region, where current Air Force planes lack sufficient range and power. They might even develop two versions, one for the Indo-Pacific and another for closer battle areas like Europe. When the American sixth-generation fighter was just entering the concept stage, DARPA considered combining the expertise of specialists from the U.S. Air Force and Navy. However, it was soon recommended that these branches develop their fighters independently. Rumor has it that DARPA aimed to foster friendly competition between the services, hoping to get two excellent new-generation fighters instead of one. Consequently, the Air Force focused on developing the NGAD, while the Navy embarked on its own FXX program. Despite various hypersonic and missile programs, stealth remains crucial for the future success of the U.S. Air Force. Making the sixth generation even stealthier might be challenging, given the near invisibility of the Raptor on enemy radars, and the even more advanced stealth of the F-35 Lightning II. The F-22 boasts some of the most impressive stealth features, with a radar cross-section of 0.01 square meters, appearing like a small marble on enemy radar. However, its high cost of $350 million is a drawback. Therefore, NGAD specialists aim to equip the sixth generation with advanced technology while managing costs to avoid burdening taxpayers. From fiscal years 2024 to 2027, the U.S. Air Force's estimated additional cost for the NGAD program will exceed $1.7 billion. Each futuristic fighter is expected to cost several $100 million, according to Secretary of the Air Force Frank Kendall. For now, let's set aside the financial concerns and look forward to the potential future characteristics of this advanced aircraft. The new fighter plane is expected to feature advanced engines that would be ready by 2025. Initially, they aimed to produce these new fighters quickly, similar to the process used in the 1950s, but they have now adopted a more traditional approach. The plan is to start using these new fighters in the 2030s once they have enough of them. Some new technologies are being tested on existing planes, like the F-22. Modern fighter engines perform optimally at a specific point in the flight envelope. To enhance efficiency at any speed and altitude, sixth-generation fighters may incorporate a variable cycle engine. This design promises better range, faster acceleration, and improved subsonic cruise efficiency. The engines will function as turbojets at supersonic speeds and as high bypass turbofans at lower speeds. Teams from General Electric with their XA100 engine and Pratt & Whitney with their XA101 are responsible for this capability, working under the U.S. Air Force's Adaptive Engine Transition Program. They aim to integrate these engines not only into NGAD fighters, but also into the existing F-35 fleet. For instance, the Raptor is renowned for its supercruise capability, a core requirement of the Advanced Tactical Fighter program that led to its development. However, supercruise consumes a lot of fuel, so it is often limited to short tactical bursts during missions. If supercruise could be sustained for longer periods without excessive fuel consumption, it would greatly reduce travel time to and from mission areas. This presents a significant challenge for the team developing NGAD. The design of the new fighter will likely deviate from traditional norms, featuring a highly streamlined shape with an elongated mixed fuselage and wings without traditional horizontal and vertical stabilizers. This tailless configuration will prioritize low observability across a broad radio frequency range to enhance survivability, while also improving aerodynamic efficiency. The fuselage materials will likely include advanced stealth coatings to conceal the aircraft from infrared detection and minimize heat emission. Combined with advanced thermal management systems, engineers must ensure that these stealth coatings remain intact and do not require extensive maintenance after each flight, even at high speeds. Another crucial consideration for the NGAD team will be the operating altitude of their next-generation fighter. The F-22, for instance, can fly at over 60,000 feet, nearing the point where pilots would need full pressure suits. Missiles launched from such heights can travel much farther than those fired from 20,000 feet below. Given the threat environment NGAD will face, which includes space and spectrum warfare, it becomes clear: the higher the altitude, the more versatile the aircraft. Higher altitudes also provide a significant line-of-sight advantage for the fighter's sensors and communication systems. At 40,000 feet, the line of sight is about 245 miles, but at 60,000 feet, it exceeds 300 miles. This extended range is a strategic asset, especially when navigating through dense enemy air defense networks. Operating at such heights not only enhances missile performance, but also maximizes the aircraft's overall situational awareness and effectiveness in combat scenarios. Like every other advanced air fighter, the NGAD fighters need constant data exchange with collaborative combat aircraft and other U.S. Air Force and Navy planes. Acting as both a quarterback and a heavy hitter, the NGAD's communication range is vital. Every extra mile of connectivity enhances the fighter's survivability and expands its operational area without relying on beyond line-of-sight repeaters like satellites. Now to one of the most important parts, the armaments. The NGAD might be equipped with more than just the standard missiles used by the F-22 and F-35. It will also feature the cutting-edge A-26A Joint Advanced Tactical Missile that is currently being developed by Lockheed Martin. Additionally, it will have long-range engagement weapons, which Raytheon is developing alongside its air-to-air missiles. For over a decade, senior Pentagon officials have praised air-breathing hypersonic systems as the weapons of the future, making them a likely addition to the NG-80's arsenal. And then there are the weaponized lasers. The U.S. Air Force is already testing lasers with 100 to 150 kilowatts of focused power as part of Lockheed Martin's Laser Advancements for Next-Generation Compact Environments program and the Self-Protect High-Energy Laser Demonstrator, a joint effort by Northrop Grumman, Boeing, and Lockheed. Using these lasers to protect NG-80 fighters from incoming enemy missiles by blinding or frying their homing systems is very possible. In June 2022, the U.S. Air Force determined that key technologies were ready to support the next phase of the program, called Engineering and Manufacturing Development. They had tested a full-scale prototype of the NG-80 fighter plane in 2020 as part of the AII X-plane program and tested 3 different prototypes by 2023. They officially requested proposals in May 2023, with plans to select a company to collaborate with by 2024. A Chinese state-backed newspaper recently revealed a tailless design for its developing 6th-generation aircraft, which looks very similar to U.S. 6th-generation fighter jet concepts. While the exact design of the U.S. 6th-generation fighter hasn't been made public, the Chinese design closely matches concepts shown by U.S. weapons manufacturers a few years ago. The Chinese newspaper, Global Times, pointed to a video from the Aviation Industry Corporation of China where this design was featured. The newspaper describes the tailless, finless aircraft as having a blended wing body design, which offers better lift, longer range, and lower fuel consumption. However, its most important feature is its stealth ability. Vertical parts like tails and fins improve speed and maneuverability, but make the aircraft more visible to radar. Protruding parts like fins, tails, and external weapons can be detected by enemy radar because they reflect electromagnetic signals. Sharp edges and tails are easier for radar to spot compared to smooth aircraft, like the B-2 bomber. This is why stealth fighters like the F-35 carry weapons internally, keeping the exterior smooth to reduce radar detection. Even with its stealthy and aerodynamic design, the new Chinese aircraft appears to resemble U.S. designs from several years ago. This similarity isn't surprising, given concerns about China's attempts to copy U.S. weapon specs through cyber espionage. It's not unexpected that the technical plans and systems for China's 6th-generation technology, as described by the Global Times in 2020, closely resemble those of the F-35. According to the Chinese newspaper, the new PLA Air Force 6th-generation aircraft will feature an autonomous computerized system to gather, organize, and present various information sources to pilots. J-20 designer Yang Wei was quoted in the 2020 Global Times article, saying that a future fighter jet will need longer range, better endurance, stronger stealth, a larger load of air-to-air and air-to-surface weapons, and the ability to provide pilots with easy-to-understand battlefield information and predictions. This focus on giving pilots clear and simple warzone intelligence is very similar to the F-35's sensor fusion. In an F-35, data from 360-degree cameras, long-range targeting, navigation, threat warnings, and other factors like speed, altitude, and angle of approach are combined, analyzed, integrated, and shown on a single screen for the pilot. China's vision for its new generation fighters closely mirrors that of the U.S. The paper explains that in an integrated system, the aircraft should connect to a network, generate real-time situational images, create multiple attack routes, and share target information across mission areas in real time. Artificial intelligence is crucial in the early design and testing of U.S. 6th-generation stealth fighters. AI will likely integrate more data sources, such as electronic warfare, space, radar warning signals, and unknown indicators into the aircraft's systems. Advanced algorithms can quickly analyze large amounts of incoming data, compare it with a vast database, and make near real-time decisions and calculations. This helps pilots make faster and clearer decisions, reducing their mental workload. These are the main goals of AI-driven programs, which is why they are a focus for the new generation of Chinese stealth fighters. Technologies like conformal sensors built into the aircraft's body, known as smart skins, are examples of innovations likely to be used in sixth-generation fighters. Other features mentioned in the Chinese report include new stealth designs, advanced weapons like lasers, adaptive engines, and the ability to control drones. While much attention has been given to the stealthy exterior of China's fifth-generation aircraft, which resembles an F-35, less is known about the internal technology of advanced Chinese fighters. The real difference in what makes a fifth or sixth-generation aircraft superior might come down to AI's role in computing, sensing, targeting, maneuvering, and various combat strategies. Thanks for watching. While you are still here, click on the link appearing on your screen to check out another of our videos. See you there.